The objective for this video is to learn how to conduct a hypothesis test for a proportion. An article in Forbes magazine stated that according to the Federal Reserve's Survey of Consumer Finances, only about 45% of American households aged 25 to 64 had balances in retirement accounts. A random sample of 1,200 people between the ages of 25 and 64 from a particular city was selected and surveyed. Of the 1,200 people surveyed, 567 had balances in retirement accounts. Test at a 0.05 level of significance the claim that the percentage of people in this city who have balances in retirement accounts is greater than the percentage for the entire nation. Certain assumptions must be met when testing hypotheses about proportions. These assumptions are: 1. The sample is a random sample. 2. The conditions for a binomial experiment are satisfied. If you have questions about that, see Chapter 5. And 3. The product of N and P, which are the sample size and the hypothesized proportion, is greater than or equal to 5, and the product of N and Q, the sample size and the complement of the hypothesized proportion, is also greater than or equal to 5. Step 1 is to state the hypotheses and identify the claim. The claim is that the percentage of people in this city who have balances in retirement accounts is greater than the percentage for the entire nation. So this will be a one-tailed test to the right. Remember that the null hypothesis always contains the equal sign. So the claim in this case is in the alternative hypothesis. Since this is a one-tailed test to the right, the alternative hypothesis will be that the proportion is greater than 0.45. Step 2 is to find the critical values. We will use the z distribution for our critical values. Note that the second line of the t-distribution table is where we will find the critical values for one-tailed tests. We should travel across to the column that is headed 0.05, since this is the specified significance level for this problem. The bottom row of this table contains the critical z-scores. This row and the one-tail 0.05 column meet at the critical z-value 1.645. Note that at the bottom of the page are some notes about rounding the critical z-values in this textbook. We will round this value to 1.65. So the critical value will be 1.65 for alpha equal to 0.05. Step 3 is to compute the test value. We will use the formula p hat minus p divided by the square root of the quotient of p times q and n. P hat is the sample proportion, which is found by dividing the number of successes by the number of observations. Of those surveyed, 567 had balances in retirement accounts, and 1,200 was the total number surveyed. This quotient can be expressed in decimal form as 0.4725. Substituting the values into the formula results in a z-test value of 1.57. Step 4 is to make the decision to reject or not reject the null hypothesis. It is always a good idea to visualize the orientation of the critical values and the test value by placing them on a graph of the hypothesized distribution. We have a normally shaped sampling distribution with a hypothesized population proportion of 0.45. If the test value lands to the left of the critical value in a right-tailed test, we do not reject the null hypothesis. In this problem, we are to test at a 0.05 level of significance. We have determined the critical z-value so that 5% of the distribution lies in the rejection region. That would leave 95% of the sampling distribution to the left of the critical value. Therefore, it would be very unlikely that our randomly drawn sample would lead us to commit a type 1 error, which is to reject a true null hypothesis. But our calculated z-test value was 1.57. This does not lie in the rejection region, so we should not reject the null hypothesis. Step 5 is to summarize the results. Since we will not reject the null hypothesis, our conclusion is that there is not enough evidence to support the claim that the percentage of people in this city who have balances in retirement accounts is greater than the percentage for the entire nation. In this video, we learned how to conduct a hypothesis test for a proportion.